two particles, each having a mass of 5 gram and charge 10 raised to the power minus 7 coulomb, stay in limiting equilibrium on a horizontal table with a separation of 10 centimeter between them. Find coefficient of friction between each particle and the table, which is the same between each particle and table. As you can see here, these are the two blue particles which are having a charge, and because of that charge, these two particles must be applying electrostatic force of repulsion between them, because both are similar charges. And in addition to that, other forces which are acting on this system. The first is weight of the charges. So let us suppose weight is mg for both, because both the particles are identical. And then weights are counterbalanced by the normal reactions by the table. So let us suppose the normal reaction is N. Okay. And because of the charge, these two particles are applying electric force. Say it is Fe, and it is repulsive force because both the charges are 10 raised to the power minus 7 coulomb of the same nature. Mass of the body is given to be 5g. So here it is the force of repulsion. Because of that, if suppose the surface of the table is smooth, then particles would have moved. But there is friction, and because of that friction, these two particles are staying in limiting equilibrium. So what does that mean? Limiting equilibrium means the force of friction must be at its limiting value. So what is the limiting value of the friction? Limiting value of the friction for a contact is always equal to mu times the normal reaction. And here you can see for any of these two particles, normal reaction must be mg. So force of friction limiting value is mu mg. Okay. And on the other hand, there is electrostatic force of repulsion between the particles. Fe is equal to 9 into 10 raised to the power 9 into q1 q2. So here the charges are 10 raised to the power minus 7, same value. So 10 raised to the power minus 7 multiplied with 10 raised to the power minus 7 divided by square of the distance. Distance between the charges is 0.1 meter, which is 10 centimeter. So 0.1 square. So this way, what you get is 9 into 10 raised to the power minus 3 Newton. So this is the electric force of repulsion acting between the particles, which is counterbalanced by the limiting friction. So what is the value of the limiting friction? F is equal to mu mg. So here mu is unknown. That is something which we have to actually calculate. And m, mass of the body, is 5 grams. So 5 into 10 raised to the power minus 3 kg into g. G we are using to be 10. So for equilibrium, this electrostatic force of repulsion must be equal to the force of friction. So on equating these two forces, we get 9 into 10 raised to the power minus 3 is equal to mu into 5 into 10 raised to the power minus 3 into 10. So what we get, 10 raised to the power minus 3 gets cancelled, and on solving, we get mu is equal to 0.18. So force of friction, coefficient of friction must be 0.18 between the charges and the table.